Okie dokie guys, let's do these questions then. I'm going to put about 20 in this set. It's 20 quadratics that look like this, usually speaking. This is in the standard form. I'd write a quadratic, the highest power first, and the terms of x and the constant at the end. So that's nicely arranged in the standard form we would expect. And we can tidy up expressions, formula, whatever, that in this particular pattern. So we've got this pattern. Now we're going to, in this section, we're solving by the method of factorization. So I'm going to put about 25 questions down. I'll front load it with easy ones so that we can get comfortable, and then we'll maybe try some slightly more awkward ones then later on in the playset. And so let's have a go at it then. Here's the bookwork that we can use to help us a memory jog, and this makes life a bit easier, I think, because I always try and find the easiest way to do something, as far as I know, and so I put it down here for you. There's a bit of bookwork for the quadratics when we solve by factorization. First line, first term. Last line, last term. And the middle lines corresponds to the middle term. Okay, so it's easy to remember. And so what we do then method-wise is we just draw a pair of brackets underneath it. And we draw 4 lines, 2 for the first, 2 for the second, label them 1, 2, 3, 4. Now it doesn't take a couple of moments, hardly a second to write down those lines, and they make life a lot easier. So the first line is the line here, line 1, yeah? So first line, first term, the first term is x squared. What times what gives x squared? Well, it's x times x. So we could put that piece in the jigsaw. That's that one done. Yeah? Now we look at the next piece in the jigsaw. Last line, this is the next easiest thing to do. Last line is the last term. The last term is minus 6. So we've got to be a bit careful here. Minus 6. So what numbers give a product of minus 6? Well, it would be minus 6 and 1. And don't forget we're putting in these two places. So you could write 1 and minus 6 to go with that, couldn't you? The other way around. And then you've got 2 and minus 3. And so you'd have minus 3 and 2. And then we'd have minus 1 and 6. And 6 and minus 1. And then we'd have minus 2 and 3. And 3 and minus 2. There they all are. That's the whole combinations here, right? And basically that's I know it looks difficult to start with, but bear with me, because it will become clear and life will get a bit easier. Now in this one, you've got an x here and an x here. So there's symmetry. Doesn't matter which position, which way around the brackets are, because there's the same number here as here. So you can actually, in this instance, cross off the repeats. And that one's just flipped around, so there's symmetry. So it's not going to make any difference the order in this problem. So we can get rid of that one. We can cross off that one. Yeah. We can cross off that one. Yeah. And we can cross off that one. Yeah, we are. So we don't actually write them down in practice. Okay, so we'd only have written down 4 things because of the symmetry. So now, that's the last line, last terms. These are all the possibilities. Now the last piece of the jigsaw is middle lines, middle term. So line 2 is this times this. That's line 2. That many x's plus that many x's is line 3. And that needs to add up to plus 1 lot of x. There's a 1 hiding here, isn't there? So there's the that many's and there's the that many's. So that many of this and that many of this, right? One of each, one of those and one of those, must add up to 1. So we look down our list and we see which one adds up to 1 of this and this. They must add up to 1. Can you see it? That one doesn't add up to 1. Nope, minus 1. There it is. There we go. That one, or the one that we crossed out because of symmetry, adds up to 1. So that's it then. So we can put minus 2 and plus 3. There we go. Now I know I dragged it out, like pulling teeth out in a sense, and made it look really, really hard. But once you get used to them, this method is fail-safe. It's just a simple way to do them. Okay, and these are the pieces in the jigsaw that we need. So don't forget also the 3 and minus 2. You can see that you could have put them the other way around. You could have put 3 and minus 2, because as I said, doesn't matter which way you write the bracket, because there's an x and an x there. So there's some symmetry there that we can take advantage of. So that is the factorization. We're letting them equal 0, aren't we? So that equals 0. So let's just tidy it up because it looks a bit of a mess. We've got x minus 2 then. x plus 3 equals 0. That's factorized. So either this equals 0 here. This product must equal 0 when either this equals 0, because 0 times that would be 0, or the product equals 0 when that is 0, because that times whatever this is will give 0, yeah? So when does this equal 0? Well, this equals 0 when x minus 2 equals 0, which means that x must have the value 2. And this one, x plus 3 equals 0, then implies x equals minus 3. So essentially, we're using the method of factorization to solve quadratic equations, and that's number 1 done. So we'll do about 20-25 until we're completely comfortable with these things, and that we get the method in our heads. Yeah, the simple little method, little pieces in the jigsaw as we work through. So as I say, sorry to drag it out a bit on the first one, but we won't dilly-dally anymore. Let's go on to the next one then. Great. Yeah. Cheers.